Hey students, today we're going to talk about pH and pOH. So here's your first equation. 1 times 10 to the negative 14th equals H plus concentration times OH concentration. So just to let you know, if it has brackets, that means it means molarity, or the concentration of it. Also, H plus is the same thing as H3O plus. So in the notes, I'm going to use H plus. The worksheet I haven't updated yet still says H3O plus. So, big thing here is it's neutral if H plus is equal to OH. It's acidic if H plus is more than OH, and it's basic if H plus is less than OH. So here's my first example. What is the concentration of an H plus? If the OH concentration is 4.2 times 10 to the negative 5th molar, is the solution acidic, basic, or neutral? So basically, what you're going to want to do is you're going to want to take that 1 times 10 to the negative 14th, and you will want to divide by your OH concentration. So they'll divide by that 4.2 times 10 to the negative 5th. Now remember, when you put it in your calculator, that you need to put this in parentheses, otherwise you're not going to get the right exponent. So you're going to take the 1 times 10 to the negative 14th divided by 4.2 times 10 to the negative 5th, put it in parentheses, and I get 2.38 times 10 to the negative 10th. And because I calculated a concentration, the unit should be molar, because this is molar. Technically, the 1 times 10 to the negative 14th doesn't have a unit. So if you look at this, this was my H plus concentration. So it looks like my OH, or my H plus, is less than my OH, because this is smaller than that, because the power 10 to the negative 10th is smaller than 10 to the negative 5th. And so this would be basic. Okay, this equation is on your equation sheet. These are also on your equation sheet. So here are all of your equations. I'm going to kind of go through them when we go through the examples. Here's your pH scale. If it's 0 to right till 7, it is acidic. Neutral is 7.00 on the dot. If it's above 7.00, it's basic. pH of a solution in which hydroxides, we want to calculate the pH, so we want the pH. So you use these equations. So basically, this equation if you're looking for pH, this equation if you're looking for pOH, this equation for H plus, this equation for OH. So I have the OH equation, or I have the OH concentration, so I cannot calculate pH. The nice thing is I can also figure out pH using this. So if I know the pOH, I can figure out the pH. So I'm going to calculate the pOH first. So I'm going to calculate the pOH first, which is your negative log of your OH concentration. And so I will take the negative log of 9.6 times 10 to the negative 9th molar. Once again, I would put this in parentheses, and it depends on how your calculator it is. If you do the log first or if you do the log after, I can help you with that in class. If you take the negative log of this, I get 8.02. So then I'm going to use this bottom equation. So my pH will equal that 8.0, my pH plus my pOH, so plus that 8.02 will equal 14. And so my pH will then equal 14 minus that answer, so 5.98. So looking at 5.98, that's less than 7, so that pH is acidic. Now I want to calculate the H plus concentration of the pH is 4.78. So I want the H plus concentration. So I want to use this equation. So I'm going to take my H plus is 10 to the negative pH. So that's 10 to the negative 4.78. That one's pretty easy to put in your calculator. Just use that caret button. And I get 1.66 times 10 to the negative 6. I have a concentration again, so I have a unit of molarity. pH and pOH, no unit. So pH and pOH, no unit at the end. Okay? Two more. So, the molarity of a strong acid. If you have a strong acid, it's H plus. If you have the molarity of a strong base, it's the OH minus. So we're going to calculate the pH of HBr. So since this is an acid, started with an H. That's how we know it's an acid. We can actually just that 0.045 molar will equal that H plus concentration. So all we have to do is take the pH equals negative log of the H plus. So negative log of 0.045 is equal to 1.35. The molarity of a strong base is equal to the OH. So we know that this one, so we're going to calculate the pH of that. It has an OH, so it ends in OH. That tells you it's a base. So that means that the OH concentration is 0.256 molar. So we're going to first calculate that pOH, and it'll be negative log of that 0.256. And I get 0.592. And so my pH plus my pOH, so 0.592 will equal that 14. So the pH will equal 13.408.